All right, guys, we are on lesson 3-12. This was the box plots, and it accidentally got copied onto your test that you guys took last week. I told you that was not going to be on there, but since I wasn't there, the person who helped me make copies accidentally copied the whole test, so don't worry about that. So let's go ahead and get started on lesson 3-12. We're on page 151. So to make a box plot, we are going to be using what is called the 5-number summary. So over here to the side where you have a little bit of room, I want you to draw a star and write 5-number summary. Now that sounds weird, but 5-number summary is some of the things you already know. We need the minimum, we need the median, we need the maximum, and then we divide in between into what we call quartile 1 and quartile 3. So when we're making a box plot, we are going to be dividing it into quartiles. If you hear the word quartiles, it kind of sounds like quarter. So that's telling you that we're going to have 4 pieces of our data on this box plot here. So this one says, a dot plot below shows how long Mr. Bard's 6th graders held the plank position in gym class. So our first 5-number summary, our first one is on letter A here, says to draw a vertical line through the minimum and the maximum. So there's 2 of our 5-number summary. So the minimum on this, someone raise your hand, tell what is the minimum? Should be on 60, so above 60, draw a vertical line like that. What is the maximum? Someone raise your hand. Should be above the 100, that's the biggest number we have. Then letter B says to draw a vertical line segment through the median to cut the first data set in half. So all of our numbers, that's our whole data set, we need to cut it straight in half. So we need to take a second and find the actual median of our data set. Our median we have to put in order from least to greatest. Since it's already a dot plot, it's already done for us. So we just start on our outermost dots and head inward. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11. And here's our median. So if we look at our number line, our median is on 78. So that is where we draw another vertical line. So underline that median again. So now we've got 3 out of our 5-number summaries done. Our minimum, our maximum, and our median. 1, 2, 3. Now it says to draw a vertical line segment through the median for the 11 data points below the entire median. So you're going to imagine that now we have these data points in their own set. We're not part of a whole thing anymore. We're only using this lower part. Hang on just a second. My dog's barking to come in again. His feet were wet and he just fell. Anyway, so the first quartile, this is our first quartile. We're finding the median of this new lower set of numbers, okay? So we're going to do the same thing that we just did, and we're going to find the middle. Someone take a minute and see if you can find the median of our new lower set. And it tells us here 11, so that means we are not using the actual median for the whole set in our lower set. So if you look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're only using these 11 data points. So who can find the median of that? you should have ended up here at this dot on 69. So that's where we're going to put a vertical line there. So that's, let's underline that median again here. And then I'm going to underline the below part. So that's the lower portion. And now we're going to do the same thing for the 11 data points above. So the median above. So that's these data points now. So take a second, find the median of our upper portion. And you should have ended up on this dot here, which is at 81. And there we go. We've got our 5-number summary. We've got our lines to show where each of those fall. And then we need to list the numbers where we wrote our line, or where our lines ended up. So this list is our 5-number summary. So we just go down the line. So our first one is 60. The next one, 69. The next one, 78. Then 81. And then 100. Now, underneath here, I want you to write the 60 is the what? What do we call that from this data set? That is our minimum. So let's write MIN under that one. 100, that is our maximum. So write MAX. 78, that is our median. And then these two in between, these are what we would call quartile 1 and quartile 3. So there's our 5-number summary. Minimum, maximum, median. And then we find the median of the lower set, and that's called quartile 1. And then the median of the upper set, and that's called quartile 3. Now, on this bottom one, on number 2 down here, we're going to make a, we're using the same dots here from this problem up here. And we're going to actually build our box plot with that. Okay, so take a second. We're going to fill in our lines. We're not gonna actually use the dot, put every single dot. We're just going to use our 5-number summary to draw our vertical lines again. So we need a vertical line above 60, a vertical line above 69, above 78, above 81, and above 100. Okay, now to complete a box plot, all you do is you connect, so here's our quartile 1 and here's our quartile 3. All you do is connect your quartile 1 to your quartile 3, and then you connect your maximum and minimum with a line through the center, like that. And there you have, that's a box plot. That's all you have to do. So the hardest part is finding your 5-number summary. Once you find your 5-number summary, the actual building your box plot is very simple. And if you look at this box plot, we talked about quartiles, right? That there are 4 equal parts. Here we go, this chunk here goes up to quartile 1. This chunk is quartile 2. This one is quartile 3. And this one is to quartile 4. So the minimum is not one of our quartiles because it has to be the whole chunk of that. So if our median fell down here, then quartile 1 would only be this big. So quartile 1 is from the minimum to here. Quartile 2 is from here to the median. Quartile 3 is from the median to this one. And then quartile 4 is from this one all the way up to your maximum. okay? Then it says, which quartile has the greatest range? Who can tell me? Who reminds us what a range is? How do we find a range? A range, remember, we find, if we were finding the range of our entire data set, we would take our maximum minus our minimum. Since we're trying to find the greatest range within the quartiles, we're looking at each of these quartiles. So from this one, it is from 60 to 69. This one goes from 69 to 78. This one from 78 to 81, and this one from 81 to 100. So is quartile 1, 2, 3, or 4 going to have the biggest range between their smallest and biggest number? And if we look, you can see that visually. Quartile 4 is much bigger. It's almost the same size as all the other quartiles put together. So quartile 4 has the biggest range. And if we subtracted all that, we would find that this would be about 9. This is also 9. This is only 3. And this one is 19. So we can tell that quartile 4 has the biggest range, both by using subtraction and by just looking at it visually. And then letter B says, explain the relationship between range and the way the box plot is drawn. So looking at it visually, that's what they're talking about there. Looking at it visually, what do you notice about the range and what you actually see in our box plot? So we can say something about that the bigger the quartile is, the greater the range is, right? The more spread out this is, the bigger our range is going to be. So we can say that the bigger the quartile, I'm not spelling that right, hang on a second. Bigger the quartile, comma, the larger the range. So we can see here that this range is going to be pretty small because our box is pretty small. And this one is going to be much bigger because it's much bigger quartile. All right, once you have that written, turn your page. And we're going to look at some box plots that are built for us and use them to help us find some answers here. So it says, the box plots show the lengths of time students from 3 different classes can hold the plank position. So we have 3 different 6th grade classes, Class A, Class B, and Class C. And we're going to use these box plots to help us answer these questions. So number 1 says, what is the quartile 3 for Class A? So if we look up here at Class A, let's put some labels on here. We know that these end lines, that's our minimum and our maximum. So from the minimum to this line, what would that be called? Someone raise your hand. This is our quartile 1. Then from this vertical line to this vertical line, that's our quartile 2. Then from this one to this one, quartile 3. And from this one to our maximum is our quartile 4. Let's see if I can zoom in a little more. There we go. So once we have those labels on, the answer is pretty easy. Who can tell what is the Q3 for Class A? If you follow our vertical line down to the number line, we end up here at 83. And then number 2, what is the quartile 1 for class B? So let's do the same thing. Take a second, let's label class B. So we know this is our minimum. So from the minimum to the second line, that is quartile 1, second line to third line, quartile 2. Erase that, got kind of sloppy there. This line to this one, quartile 3, and this one to our last one is quartile 4. So what is quartile 1 for class B? If we follow that down, we end up there at 65. And what is the range for class C? The range for the whole class. So we don't even need to worry about labeling our quartiles on this one, because when we use the range for the whole set, what do we use? We use our maximum and we use our minimum. So we don't even need to worry about labeling anything else on there. So we end up, here's our maximum at 96 and our minimum is 45. So 96 minus 45 gives us 51. And then 4A, which class has the greatest range of times? So looking at that visually, looking at those 3 classes, which one has the biggest range from their maximum to their minimum? If we look at that visually, we can see that class B overall has a much bigger range than class A or class C. So we would say class B. And what can we say on 4B there? What can that tell us about that class? Pretty simple, really. We could just say that they have the greatest range between their maximum and their minimum. They have the greatest range between the maximum, I'm just going to put max period, and minimum. Looking at 5A, in which class were the students' times closest to one another? So if we look back up at our 3 classes, which one would have times that were closer together versus being more spread out? And again, we can look visually. So letter class B had the biggest range. So the smallest, the ones that with the class closest together, then we can look for the visual of here's class C versus class A. So it's going to be class A. Class A, and then explain how we know that. So I'm going to give a sentence about how we know that class A has numbers closer together. So we can say that class A has the smallest range, which tells us that the numbers will be closer together. Class A has the smallest range. So that means the data is closer together. That was sloppy. Class A has the smallest range, so that means the data is closer together. And then number 6 says which classes students held the plank position longest. So looking back up at our classes, which classes students held it the longest? This one's a little trickier, so take a second looking at those 3. And what do you guys think? I would say probably Class A here, because if you look at all of theirs, like we said, they have the smallest range, so all of their kids held it between 65 and 93 seconds. Where if you look at Class B, we don't really know how many dots there would be for this. But Class B, we have one kid that only held it for 35 seconds. So we know that there are some that are down here lower. So most likely it's going to be Class A again for number 6. The camera's going to fall over. And we can explain by saying that Class A has the smallest range and their minimum is the highest as well. So if you look at our minimum for Class C also, Class C's minimum is 45. So Class A's minimum, the shortest amount that any kid in Class A held it, was 20 seconds longer than any kid in Class C and 30 seconds longer than the kid in Class B. So we can say that Class A has the smallest range and the highest minimum. Class A has the smallest range and the highest minimum. And then number 7, which class has the most students? If you look back up at the 3 box plots, can we tell which class has the most students? Do we know how many data points fall on that line or on this line? That's the downside of only having the box plot and not having the actual data set, is that we can't tell how many kids are in each class. We could have a class where there were only 5 kids and those were each of their data points. So on number 7, we would say we can't tell. I'm just going to shorten it since they gave such a small line there. and put can't tell. All right, so that's the end of lesson 3-12, and you will have your home link 3-12 to go along with this lesson for today.